Hi, some time ago I've built an audio speaker out of a light bulb. When connected to a powerful enough amplifier and placed in a strong magnetic field, almost anything will produce sound. Today we will continue this experiment and try this trick on another toy, my trusty shop vac. It is a simple but sturdy model which can be used for cleaning a garden, rakes work better, or declogging a toilet, but you have to clean the vac after, so don't do this. Now let's try using it a bit more. It doesn't have a speed regulator, and to the best of my knowledge, the power cord is connected directly to the motor. Conveniently, the motor coil resistance is 9 ohm, which is in order of typical speaker resistance, so I can connect it directly to the amplifier.
Yes, you have already noticed that the sound quality has just degraded. This is because you are listening to me through the vacuum cleaner.
Now let's play some music. Wow, this quality definitely sucks. Thing is, if there is enough power on low frequencies, the motor will start spinning. Consider this to be an extreme case of resonance. Let's cut out these frequencies. Much better, but there still is a lot of distortion. To understand why this happens, let's test our speaker on something very simple. For sound, and actually for any long periodic data, the common way is to dissect it into a sum of sine waves. This is called a Fourier transform. Let's sweep over frequencies and see how it responds. Now we can analyze each frequency separately and then just sum the results together. There can be situations when this assumption breaks. For example, when we go below 200 Hz, the motor starts spinning, which, besides being loud, is likely to affect how it reacts to all other frequencies. But for a vast majority of applications, Fourier transform is a magic wand that makes impossible things pretty simple. Unlike a regular speaker where we just see a straight line, on the vacuum we see many strong resonances on multiples of the main frequencies. This distorts the sound. The second harmonic is actually stronger than the main signal, and this is why my voice through the back sounded more high-pitched. We also get very little response above 5 kHz, which is kind of expected as the motor is really heavy. And when we get below 400 Hz, all the hell breaks loose, so we need to suppress these frequencies. So overall, I can't recommend this speaker 2 out of 10, and that's only because it works surprisingly flashy for selected compositions.